Greetings on the QUASARIA channel. Today we will embark on a journey to one of the most mysterious and majestic objects in the universe, a galaxy that exists in absolute cosmic isolation. This is the story of IC 1101, the loneliest giantess in the ocean of void. Imagine a galaxy so enormous that our Milky Way would look like a grain of sand next to a soccer ball in comparison. Now imagine that this galaxy drifts in absolute darkness, surrounded by emptiness for millions of light years in all directions. This is IC 1101, a titan among galaxies and the loneliest object we have ever discovered. IC 1101 is a supergiant elliptical galaxy located at a distance of more than 1 billion light years from us, in the center of the Able 2029 cluster. Its diameter is about 6 million light years. For comparison, our Milky Way has a diameter of only about 100,000 light years. IC 1101 is 60 times larger. This galaxy contains about 100 trillion stars. That's 1,000 times more than in our galaxy. If you could travel at the speed of light, it would take you 6 million years to cross it from one edge to the other. How did this giantess appear? IC 1101 is the result of cosmic cannibalism stretched over billions of years. This galaxy has absorbed hundreds, possibly thousands of smaller galaxies on its path. Each collision added to its mass, increased its size, turning it into the monster we see today. At the center of IC 1101 hides a supermassive black hole with a mass of 40 to 100 billion solar masses, one of the most massive black holes known to science. This is the gravitational heart of the galaxy, which keeps trillions of stars under control. But the most striking thing about IC 1101 is not its size, but its surroundings. More precisely, their absence. The galaxy is located in the center of a cluster, but it itself is surrounded by huge regions of almost empty space. The nearest large galaxies are at distances that seem staggering even by cosmic standards. This isolation makes IC 1101 a kind of cosmic island, a civilization of galaxies, if you will, that exists in an ocean of nothingness. Light from the nearest neighbors travels to it for millions of years. If an intelligent civilization existed in IC 1101, it would look at the sky and see only a handful of distant points of light in infinite darkness. IC 1101 is not just lonely, it is dying. This is an old galaxy in which virtually no new stars are born. All the gas and dust necessary for star formation have long been exhausted or dispersed. The stars in it are mainly old red and yellow giants, slowly burning out luminaries of past epochs. Billions of years ago, IC 1101 was probably a bright, seething cauldron of star formation. Galaxy collisions generated waves of new star births, creating fireworks of supernovae and the formation of young blue giants. But those times are long gone. Now the galaxy is immersed in a quiet, slow extinction. Most of the stars in IC 1101 are red dwarfs and old yellow stars, similar to our sun in its declining years. They shine dimly, quietly, without the drama of youth. This is a retiree galaxy that has lived a turbulent life and now simply exists, watching the slow flow of cosmic time. Try to imagine what it would be like to live in such a galaxy. If somewhere among the trillions of stars of IC 1101, there existed a civilization that had reached the technological level for interstellar travel, their reality would be completely different from ours. When we look at the night sky, we see Andromeda, our neighbor, which is only 2.5 million light years away. We see the galaxies of the local group, the Magellanic Clouds. Our universe seems densely populated, but in IC 1101, their astronomers would look through telescopes and see an almost empty sky, rare distant points of light, separated by enormous distances. For such a civilization, the concept of neighboring galaxies would be almost absurd. A journey to the nearest significant galaxy would take not millions of years at near-light speed, but tens of millions. This is isolation of a completely different order. This is loneliness on a cosmic scale. But IC 1101 holds even more secrets. Like all massive galaxies, it is surrounded by a huge halo of dark matter, an invisible substance that makes up about 85% of all matter in the universe. This halo extends far beyond the visible boundaries of the galaxy, possibly for a distance of tens of millions of light years. Dark matter does not emit light, does not absorb it, does not interact with ordinary matter in any way except through gravity. But it is its gravitational influence that holds the galaxy together, preventing trillions of stars from flying apart in different directions. IC 1101 is not just a visible galaxy. It is an island of visible matter floating in an ocean of invisible matter. Imagine all this mass, all this matter surrounding the galaxy is absolutely invisible. If you could see dark matter, IC 1101 would look hundreds of times larger than it appears now. A giant ghostly sphere, inside which the luminous visible galaxy would be just a tiny core. Let's return to the black hole at the center of IC 1101. A mass of 40 to 100 billion suns is unimaginable. The black hole at the center of our Milky Way, Sagittarius A-, has a mass of about 4 million suns. The IC 1101 black hole is 10,000 to 25,000 times more massive. The event horizon of such a black hole would have a diameter larger than Neptune's orbit. If you replaced our solar system with this black hole, it would swallow not only all the planets, but also space far beyond the Kuiper Belt. Entire planetary systems could rotate inside the event horizon, already doomed, but not yet having reached the singularity. The gravity of IC 1101 is so powerful that it warps space-time itself around it. When light from more distant galaxies passes by IC 1101, it bends, creating a gravitational lensing effect. Astronomers use this effect to study both IC 1101 itself and objects located behind it. Sometimes this effect creates multiple images of the same distant galaxy, smeared into arcs or rings around IC 1101. This is called an Einstein ring, direct visual confirmation that mass warps space, as Albert Einstein predicted more than a century ago. What awaits IC 1101 in the future? The galaxy will continue to age slowly. Its stars will burn out one by one, turning into white dwarfs, neutron stars, or black holes. Through trillions of years, even the longest living red dwarfs will go out. Ultimately, through an indescribably long time, IC 1101 will become a ghost galaxy, a collection of dead stellar remnants, invisible in the optical range, emitting only a faint infrared glow. The black hole at the center will slowly evaporate through Hawking radiation, a process that will take 10 to 100 years or more. But there's something even more eerie. The universe is expanding, and this expansion is accelerating. Due to dark energy, a mysterious force opposing gravity on cosmological scales, galaxies are moving away from each other faster and faster. For IC 1101, already isolated, this means that its loneliness will only grow. Distant galaxies that it can still see will gradually disappear beyond the cosmological horizon, the boundary beyond which objects are receding faster than the speed of light due to the expansion of space between us and them. Through trillions of years, any hypothetical civilization in IC 1101 would look at the sky and see nothing at all except the stars of their own galaxy. The rest of the universe would disappear, carried away by the expansion of space-time. They would be locked in an island universe, having no way to know that trillions of other galaxies once existed. IC 1101 makes us think about our place in space. We live in a relatively densely populated region of the universe, in a galaxy that is part of the local group, which in turn is part of the Virgo supercluster. We have neighbors. We have context. But IC 1101 reminds us that the universe is not the same everywhere. There are places of unimaginable loneliness, where the distances between structures are so great that the word void takes on a completely new meaning. This is a galaxy that exists in its own isolated bubble of reality. And yet, despite this loneliness, IC 1101 continues to exist. Its trillions of stars continue to shine. Its black hole continues to hold everything together. Its dark matter continues to envelop all this in an invisible embrace. It is a witness to cosmic epochs, having survived countless galactic collisions, observing the slow unfolding of cosmic history from its lonely post in the void. Interestingly, the fate of IC 1101 may show us our own future. Our Milky Way and the Andromeda Galaxy are now moving toward each other at a speed of about 110 kilometers per second. In about 4.5 billion years, they will collide, beginning a cosmic dance of merger that will last billions of years. The result of this collision? A giant elliptical galaxy that astronomers have already jokingly dubbed Milkomeda or Andro-Milky Way. This new galaxy will be in many ways similar to IC 1101. Huge, elliptical, with reduced star formation. We will witness, or rather, our distant descendants, the transformation of our home into something similar to this lonely giant. But there is a key difference. Our future merged galaxy will not be so isolated. The local group of galaxies will remain relatively bound by gravity, creating an island of structure in the expanding universe. IC 1101 has already gone through this path billions of years ago and remained in isolation. Inside IC 1101 are hidden structures that we are only beginning to understand. Globular clusters, dense groups of old stars, are numbered here not in hundreds as in the Milky Way, but in tens of thousands. Each such cluster contains hundreds of thousands or millions of stars, packed into a sphere with a diameter of only a few dozen light years. Imagine the sky on a planet in the center of such a cluster inside IC 1101. Thousands of stars would be visible to the naked eye, brighter than Venus in our sky. Night would turn into eternal twilight, illuminated by the light of countless suns. But even there, looking outward through the dense veil of stars of their cluster, an observer would see the same void surrounding the galaxy. Astronomers studying IC 1101 find traces of its turbulent past. In its outer regions, tidal streams have been discovered, elongated rivers of stars left over from galaxies that were torn apart by icy 1101's gravity millions or billions of years ago. These are cosmic scars, reminders of galactic cannibalism. Some of these streams extend for hundreds of thousands of light years, wrapping around the host galaxy like ghostly tentacles. Each stream is a tombstone for an entire galaxy that was once a separate world with its own stars, possibly its own planets, maybe even its own life. Now all this is just part of IC 1101. What about planets? In a galaxy with 100 trillion stars, there must be trillions of planetary systems. Most of the stars in IC 1101 are old, which means that their planets, if they exist, are also ancient, worlds that have existed for billions of years. Some of these planets could have been habitable. Perhaps somewhere in the expanses of IC 1101 intelligent life existed or still exists. But what would their history be like? What philosophy would they have developed? Looking at a sky full of stars of their own galaxy, but practically devoid of external galaxies. Perhaps their scientists would have spent centuries arguing about whether their galaxy is the entire universe or whether something exists beyond it. Those rare points of light, distant galaxies, could be a source of endless theological and philosophical debates. Imagine a religion built around the idea that their galaxy is all there is, created in an ocean of absolute nothingness. IC 1101 is also a window into cosmic history. The light we see from it left the galaxy more than 1 billion years ago, when the universe was younger, when the first multicellular organisms were just appearing on Earth. We're looking not just into space, but also into time. The galaxy also bathes in relic radiation, the afterglow of the Big Bang, which permeates the entire universe. This radiation, the microwave background noise of space, is slightly warmer in regions around massive structures like IC 1101 due to the Sunyaev-Zeldovich effect. By studying this distortion, astronomers can learn more about the mass and structure of the galaxy. Although IC 1101 is now calm, there is evidence that in the past, its central black hole was active. When a black hole actively absorbs matter, it becomes a quasar, one of the brightest objects in the universe, emitting more energy than thousands of galaxies combined. Giant jets could burst from the vicinity of the black hole, streams of matter and energy accelerated to near-light speeds, extending for millions of light years. These jets heated the surrounding gas, preventing it from cooling and forming new stars. Perhaps this is why IC 1101 is now so dead. Its own black hole-killed star formation. Now that era has passed, the black hole sleeps, only occasionally swallowing a random star that came too close. But traces of that turbulent era are still visible in the structure of hot gas surrounding the galaxy, bubbles and cavities blown out by ancient jets. In IC 1101, time flows a little differently. Due to gravitational time dilation predicted by Einstein's general theory of relativity, clocks in deep gravitational wells run slower. At the center of IC 1101, near its monstrous black hole, time flows noticeably slower than at the edges of the galaxy. If two identical civilizations began to develop simultaneously, one in the center of the galaxy, the other on the periphery, the one in the center would experience less time by the moment they met. The difference would be small, but measurable. The entire galaxy exists in a slightly curved flow of time, where each region experiences eternity in its own slightly different way. The stars in IC 1101 are enriched with heavy elements, what astronomers call metals, all elements heavier than hydrogen and helium. This is the legacy of generations of stars that lived, synthesized heavy elements in their cores and died as supernovae, scattering these elements into space. Every atom of carbon, oxygen, iron, and IC1101 was created in the nuclear furnace of a star or in a supernova explosion. The galaxy is a giant alchemical laboratory that over billions of years has transformed the simple hydrogen of the Big Bang into a rich zoo of elements of the periodic table. But since star formation has stopped, this process of chemical evolution has practically stopped. IC1101 has reached its chemical equilibrium. It no longer creates new elements in significant quantities. This is a chemically dead galaxy, frozen in its current state. Around IC1101, hundreds or thousands of dwarf satellite galaxies may be orbiting, tiny galaxies containing from millions to billions of stars. Many of them are too faint for us to detect from Earth at such a huge distance. They are like moths circling around a distant lantern. These dwarf galaxies are slowly spiraling down toward IC1101, doomed to eventually be absorbed. Each such galaxy will add a few billion stars to the already monstrous mass of IC1101. The process of cannibalism continues even now, just at a slower pace than billions of years ago. If we could somehow hear IC1101, what would we hear? There is no air in space, no medium for transmitting sound. But if we could convert the galaxy's various emissions into sound, we would hear a deep, almost inaudible bass note. Gravitational waves from interacting black holes, rhythmic pulsations of rotating neutron stars, the static of X-ray radiation from hot gas. This would be a symphony on a cosmic scale, but performed in extremely low frequencies stretched over millennia. One note could last 1,000 years. This is the music of eternity, a composition that no one will ever hear in its entirety. IC1101 still emits a huge amount of energy, despite the absence of star formation. Trillions of old stars continue to shine, albeit more dimly than in their youth. But the main source of the galaxy's energy now is not nuclear fusion in stars, but more exotic processes. Hot gas surrounding the galaxy at temperatures of millions of degrees radiates in the X-ray range. This gas was heated by ancient supernova explosions, jets from the black hole, and gravitational compression when falling into the galaxy's gravitational well. The mass of this gas is comparable to the masses of billions of stars, but it is so rarefied and hot that it is invisible in the optical range. White dwarfs, remnants of stars like our Sun, slowly cool down, radiating stored heat over trillions of years. Neutron stars rotate, generating powerful magnetic fields and emitting radio waves. Black holes, including the central supermassive one, warp space-time around them, creating gravitational lenses and occasionally swallowing random matter with a bright burst of energy. Each star in IC1101 is a separate story, a separate fate. Among 100 trillion stars, there are red supergiants on their last breath, ready to explode as supernovae. There are binary systems where a white dwarf slowly absorbs matter from its companion, preparing for a thermonuclear explosion of type I. There are planetary nebulae, dying stars that have shed their outer shells, creating glowing clouds of gas of bizarre shapes. Each such nebula shines for only a few tens of thousands of years before dispersing, a moment by cosmic standards, the last gasp of a star before turning into a white dwarf. There are rogue stars, ejected from the galaxy by gravitational interactions, flying through intergalactic void at speeds of thousands of kilometers per second. These lonely stars will never return home, doomed to wander in the void forever until they burn out billions of years later. There are hypervelocity stars, accelerated to several thousand kilometers per second during a close passage near the central black hole. They rush through the galaxy like cosmic bullets, some having gained enough speed to leave the galaxy forever. If civilizations ever existed in IC 1101, and statistically, in a galaxy with 100 trillion stars, at least a few should have emerged, what would their chances of survival be? An old galaxy with low activity may seem like an ideal place. Fewer supernovae, fewer cosmic catastrophes, a stable, predictable environment. But there's also a flip side. In such a galaxy, fewer heavy elements are formed now, fewer new stars and planetary systems. Any civilizations that arose here are probably very ancient, perhaps billions of years old. What happens to a civilization that exists for so long? Maybe they reached a post-biological stage, uploading their consciousness into computers or other substrates. Maybe they built Dyson spheres around billions of stars, collecting every photon of energy. Maybe they died out long ago, leaving behind only ruins and dead megastructures drifting in space. Archaeological monuments on a galactic scale. Or maybe they exist in slowed time, their civilization operating at such low energy levels that one of their thoughts takes thousands of years. They could be immortal, practically eternal, observing the slow extinction of a universe in philosophical contemplation stretched over eons. IC 1101 is a source of gravitational waves, ripples in the fabric of space-time. When stellar mass black holes merge inside the galaxy, and this happens regularly in such a large stellar population, they create gravitational waves that propagate in all directions at the speed of light. By the time these waves reach Earth, having traveled more than 1 billion light years, they are incredibly weak. Space-time oscillates by less than a fraction of the size of a proton. But our detectors, such as LIGO and Virgo, are sensitive enough to detect them. Each detection is a message from the distant past, an echo of a cosmic catastrophe that occurred when complex life was just emerging on Earth. Even the central black hole of IC 1101 creates ultra-low frequency gravitational waves. If another massive black hole falls into it, which can happen when the galaxy absorbs a large satellite, the merger process generates waves with a period of months or years. These waves are too slow for ground-based detectors, but future space observatories, such as LISA, will be able to detect them. Let's change our temporal perspective for a moment. For a human, the life of IC 1101 seems static. The galaxy appears unchanged not only over one human lifetime, but over thousands or millions of years. But if we could speed up time, viewing billions of years in seconds, we would see a completely different picture. The galaxy would pulsate with life. We would see waves of star formation rolling through its disks billions of years ago when it was younger. We would see victim galaxies falling into IC 1101, torn apart by tidal forces, their stars scattered into long streams, and then assimilated into the body of the host galaxy. We would see the central black hole periodically flaring up as a quasar when a large mass of gas falls into it, then fading back into darkness. We would see stars being born, living and dying, entire stellar populations replacing each other like generations of people, only stretched over incredible periods of time. And we would see the slow, inexorable reddening of the galaxy. As young blue stars die and are not replaced by new ones, the galaxy becomes increasingly red, increasingly dim, slowly fading into the cosmic night. Let's look into the very distant future of IC 1101. Through 10 to 14 years, 100 trillion years, all stars will go out. Even the longest living red dwarfs, which can burn for trillions of years, will eventually exhaust their fuel. The galaxy will become a collection of black holes, neutron stars, and white dwarfs drifting in the dark. But this is not the end yet. Through 10 to 20 years or so, these remnants will begin to fall toward the center of the galaxy. Gravitational interactions between objects gradually change their orbits. Some objects will be ejected from the galaxy forever, carrying energy with them. Others will fall inward, eventually absorbed by the central black hole, which will grow even larger. Through 10 to 40 years, thanks to quantum tunneling, even the most stable atoms of matter will begin to decay. White dwarfs and neutron stars will turn into an exotic form of matter or collapse into black holes. The very structure of matter will begin to fall apart at a fundamental level. Through 10 to 100 years, a goo years, even black holes will evaporate through Hawking radiation. The central supermassive black hole of IC 1101 will be one of the last structures in the local universe to disappear. But eventually, even it will disappear in a flash of gamma radiation. And at the site of the once magnificent galaxy, there will remain nothing but a rarefied sea of elementary particles and radiation. An interesting philosophical question arises. If there are no observers in IC 1101, does it exist for real? Quantum mechanics suggests that observation collapses the wave function, turning potentiality into actuality. But a galaxy 8 billion light years away from us, which virtually no one observes. From the perspective of the anthropic principle, we can observe IC 1101 only because we exist in a type of universe where such structures can form. If the physical constants were slightly different, galaxies could not form at all, and there would be no observers wondering about their existence. IC 1101 in this sense is evidence of the fine-tuning of the universe. The gravitational constant, the rate of expansion of the universe, the ratio of matter and dark energy. All these parameters must be in a narrow range of values for galaxies to exist long enough for the development of complex structures, stars, planets, and possibly life. IC 1101 contains an unimaginable amount of information. The position and velocity of each of 100 trillion stars, the composition of each planet, the history of each atom. If life or civilization existed somewhere there, then their histories, cultures, scientific discoveries, all this is information encoded in the structure of the galaxy. What happens to this information when stars die? When matter falls into black holes? There is the famous information paradox of black holes. According to quantum mechanics, information cannot be destroyed, but according to general relativity, everything that falls into a black hole is lost forever behind the event horizon. Stephen Hawking spent decades trying to solve this paradox. His solution suggests that information is somehow encoded in the Hawking radiation emitted by the black hole. But if this is so, then information about all civilizations that ever existed in IC 1101 and were absorbed by its central black hole still exists somewhere in a quantum state. In principle, with infinitely advanced technology, one could extract this information from Hawking radiation and reconstruct everything that ever fell into the black hole. The history of entire civilizations, recorded in quantum correlations of particles, a library on a cosmic scale, encoded in the very fabric of space-time. Some theories, such as eternal inflation, suggest the existence of a multiverse, an infinite set of universes with different physical laws and constants. If this is true, then our universe with its IC 1101 is just one an infinite set of possibilities. In some of these universes, IC 1101 would never have formed. In others, it could be even larger or smaller. In others, the laws of physics are so different that galaxies cannot exist at all. Perhaps there are universes where IC 1101 is full of life, civilizations engaged in cosmic engineering on a galactic scale. But we are in this universe, observing this particular IC 1101, lonely, quiet, slowly dying. This is our reality, our window into cosmic history. And in some sense, this makes it special, unique, despite the possibility of infinite alternatives in a hypothetical multiverse. There is something deeply poetic about the existence of IC 1101, the greatest galaxy we know, existing in the loneliest place. It's like a cosmic metaphor. The bigger you become, the more isolated you find yourself. Perhaps this is a lesson about the nature of growth and ambition, written in the language of stars and space-time. Or maybe it's a reminder that size and grandeur do not necessarily mean significance or connection. IC 1101 is huge, but it is lonely. Our Milky Way is much smaller, but we are part of a living community of galaxies, connected by gravity and common history. Ancient philosophers pondered the nature of loneliness and connection. IC 1101 gives us cosmic context for these reflections. On the scale of the universe, even galaxies can be lonely. Even structures containing trillions of suns can exist in isolation, surrounded by a void so vast that it turns the very concept of neighborhood into an abstraction. IC 1101 was discovered in 1790 by William Herschel, although no one understood what it was at the time. It took more than a century before astronomers realized that these nebulae were actually entire galaxies, island universes similar to our own. Edwin Hubble in the 1920s revolutionized our understanding of space by proving that these objects are far beyond the Milky Way. Suddenly, the universe became unimaginably larger. We realized that we do not live at the center of all existence, but on the outskirts of one rather ordinary galaxy among billions of others. Each new generation of telescopes revealed new details of IC 1101. The Hubble Space Telescope showed its structure with unprecedented clarity. X-ray observatories, such as Chandra, revealed hot gas surrounding the galaxy. Radio telescopes detected traces of ancient black hole activity. Each observation is an active connection through space and time. The photons we capture left IC 1101 more than 1 billion years ago. They traveled through expanding space, past countless other galaxies, through the cosmic web of matter and void, to finally reach our planet and hit our detectors. IC 1101 is not just a distant object to study. It is a mirror reflecting the possible future of all galaxies, including ours. Through tens of billions of years, when dark energy tears apart the cosmic web, when the last galaxies collide and merge, when star formation stops everywhere, the entire universe will look like IC 1101 looks now. Quiet, dark, filled with remnants of past grandeur. Ghost galaxies drifting in infinite void, each increasingly isolated from the others due to the inexorable expansion of space. IC 1101 shows us not only a distant place, but also a distant time, the ultimate fate of all structure in the universe. If somewhere in IC 1101 there are still intelligent observers, the last representatives of ancient civilizations that have survived billions of years of evolution, what do they feel? Do they know that their galaxy is dying? Do they understand the cosmological loneliness of their position? Perhaps they accepted this long ago. Perhaps their philosophy is built on accepting finitude, the inevitability of entropy, the beauty of slow extinction. Or maybe they're still fighting, using technologies we cannot even imagine to prolong existence, capturing every photon of energy from dying stars, building structures around black holes to extract their rotational energy. Or maybe they are just observing, recording, creating the last great library, an archive of everything that ever was in their galaxy, sealed in the most stable structures of matter they can create, hoping that someday, trillions of years later, someone or something will find these records and learn that here, in this lonely galaxy, there once existed life, thought, beauty. We humans live in a privileged cosmic era. The universe is only 13.8 billion years old. It is young by cosmological standards. Stars are still forming. Galaxies are still interacting. The sky is still filled with light from billions of galaxies. If we were born a trillion years in the future, we would look at the sky and see almost nothing. An intelligent civilization arising in that distant era might never learn about the existence of other galaxies, about the Big Bang, about the expansion of the universe. They would be locked in their own island galaxy, surrounded by absolute darkness. But we can observe IC 1101 and billions of other galaxies. We can study the relic radiation of the Big Bang. We can reconstruct cosmic history from the first moments after the beginning of time to today. We live in a moment when the universe is still telling its story to those who are ready to listen. IC 1101 sends us a message through a billion light years of space and time. This message speaks of grandeur and decline, of growth and isolation, of the temporality of even the most grandiose structures. It is a reminder that nothing is eternal. Even a galaxy the size of 100 Milky Ways will eventually fade. But it is also a message about beauty and resilience. IC 1101 continues to exist. Its stars continue to shine. Its structure persists for billions of years, despite everything. It is a witness to cosmic epochs, a monument to the processes that have shaped the universe from the very beginning. And in its loneliness, IC 1101 is not quite alone. Its light reaches us. We observe it. We reflect on it. We learn from it. In some sense, by observing it, we create a connection through the abyss of space and time, a connection of consciousness and understanding that transcends even the most vast voids. IC 1101, the loneliest galaxy we know, a giant in the void, a titan surrounded by nothing. But it is also a teacher, showing us the nature of the universe, the fate of all structures, the beauty and melancholy of cosmic evolution. Next time you look at the night sky, remember, somewhere out there, beyond what the naked eye can see, beyond a billion light years of darkness, there exists a galaxy so huge that our home seems like a speck of dust in comparison. It drifts in its isolation, slowly fading, but still majestic, still beautiful, still telling its story to the few who look far enough to see it. IC 1101, the loneliest giantess of the universe, witness of eternity, monument to the temporality of all existence. Thank you for being with us on this journey to the edges of the observable universe. If you enjoyed this video, support the QUASARIA channel with a like and subscription. We have many more cosmic mysteries to explore ahead, many stories about the grandeur and mysteries of the universe. Remember, we are all made of stardust, and when we look at objects like IC 1101, we are looking at our cosmic genealogy, at the processes that created the atoms in our bodies, at the forces that shaped the universe billions of years before our birth, and will shape it trillions of years after we're gone. See you in the next video. Keep looking at the stars and asking questions. The universe is infinitely amazing, and we are only beginning to understand its mysteries. This was QUASARIA, exploring space together.